Special report. The flight of Apollo 10. Brought to you by Western Electric, manufacturing and supply unit of the Bell System, as part of our continuing coverage of important news events. Reporting from the CBS News Apollo headquarters in New York, correspondent Walter Cronkite.
The two Apollo 10 spacecraft have now disappeared again behind the far side of the moon. Signal was lost to Earth just a few moments ago, and this is an important pass behind the moon, because this time, back there, where they have no communication with the Earth, Tom Stafford and Eugene Cernan in the lunar module called Snoopy will be firing their engines to bring them back on this next time around to the near side of the moon to within 10 miles of the moon's surface. The exact distance, 9.3 miles, if all goes as they plan, just about 50,000 feet over the moon's surface. They should reach that point at 5:32 p.m. It's just a few miles, about 18 miles before the lunar landing site number 2, which is the preferred site for the landing now expected in July of Apollo 11. They just a few moments after that will be passing over the landing site at 5:36. About 4 minutes later, they'll be over the landing site, and then they will have begun their climb back out to an altitude of 212 miles as they get behind the moon on that revolution of the moon, their 14th. When they come around the next time, around 7:30 p.m. that will be, they will then come down to within 11 miles in that same point over the moon's surface, roughly. They fire their engines and go back to rendezvous and to redock with the command module at 10 o'clock tonight. The actual docking coming at 11:19 p.m. So far today, they've had some very high moments of this flight, no pun intended, as they're out there circling the moon. There have been some dramatic moments. Some of them have lasted for a couple of hours, some for just a few moments. There have been some moments of concern about the flight of Apollo 10 today. The first little hitch came right after Eugene Cernan, and then Tom Stafford climbed into the lunar module this morning after they awakened after a good night's sleep. They got down there and found that their communications back with John Young, left alone in the command module, weren't too good, nor with the ground. They finally got those straightened away, and communications have been nearly perfect ever since. And then at 1 o'clock this afternoon, as they were pressurizing the various parts of the spacecraft, they found that the 3-foot tunnel that joins the two spacecraft, they could not vent the pressure from it, and that gave them a major cause for concern. They finally decided that they could go ahead with the mission without venting the pressure completely there, getting it down to, just about 2/3 of what it should be, which would be 0. Instead of 5 pounds per square inch, they got it down to 3.5 pounds per square inch. But then a new problem developed. And because they could not depressurize that area, additional friction was set up in their docking configuration, their rings, and there was some fear that they might cause damage to those rings, which have to work when they come back and redock if they are to successfully redock and get back between the two modules. Well, they were behind the moon by the time the final test had to come. The strain did not become as great as the ground feared and Houston control. They'd given them some constraints, said if it got to a certain point, they could not go on with the mission. It did not get to that point. They separated as planned, and now they are separated. They made the pass around the moon in their separated configuration with the lunar module Snoopy just about 35, 40 feet out from the command module, Charlie Brown. They then separated even further and now have disappeared to the far side of the moon for this next important maneuver, which is scheduled to come at precisely, let me give you the moment, 4:35 p.m. That's when Stafford and Cernan in the lunar module fire their descent propulsion system engine. That's an engine that is throttleable. It can be throttled from 1,000 to 9,000 pounds of thrust. They fire that for the first time, giving it its first major test. They brake, in effect, as the far side of the moon so that they slow down and drop toward the moon. down to that 10-mile altitude. The next maneuver at 4:35, and then swooping down to the moon's surface at 5:32 p.m. Nelson Benton and Scott McLeod at Grumman Aircraft in Bethpage, Long Island, can tell us what's going on in that lunar module right now.
Walter, we're sort of looking forward to one of the things that will be going on after that descent orbit insertion. When the LEM goes down and gets down to that 50,000 foot point, one of the tests that has to be made is the LEM's altimeter. Anytime you are going to make a control landing on a surface, it's a good idea to know how high you are. Since normal altimeters are actuated by barometric pressure, and since there is no atmosphere on the moon, LEM 4 is carrying a small pod about the size of a double-loaf bread box right under the descent stage of the vehicle. It is a radar pod that looks around at the lunar surface. This does the looking, and it feeds what it sees into the cockpit. And Scott McLeod, how do you read what the radar is showing?
Well, Nelson, up here in the cockpit, what we have is an altitude rate on these two indicators, and also we have our forward and lateral velocity on this cross pointer. Primarily, we will get our best indications of those readings on the next flight, that's Apollo 11. This flight, Apollo 10, we will evaluate the radar, but really the proof of the pudding is the following flight.
Walter, the radar works much better. It actually sees very well down at about 18,000 feet, but it will work this time a bit like flying an aircraft over Pittsburgh, and the Washington Control Center can't see you very well, but it may just get some indication that you're there, and that's the kind of test we're having this time.
They did have some difficulty a little earlier, too. One of those high points of drama that we mentioned but we failed to itemize was that after they settled the depressurization and the friction on the docking ring problem, then after they had separated and were checking out the radar, they suddenly found that part of the radar, not that landing radar, but the radar used to rejoin the command module later on tonight did not seem to be working. Turned out that a power switch needed to be thrown that apparently had not been, or at any rate, they got it straightened out, but it gave them 2 or 3 very bad minutes. One of the problems in this flight, of course, is the fact that every orbit of the moon for 45 minutes out of the 2-hour time for that revolution, they disappear behind the far side of the moon, and the ground control wants everything working properly to give them a go for those vital maneuvers, all of which take place behind the moon. Since that's the case, they have just 1 hour and 15 minutes to settle any problems they've got while they've still got contact with the ground, or else the ground would not give them a go for each of these stages of the flight. CBS News color coverage, the flight of Apollo 10, will continue in a moment. So with Charlie Brown sitting there all alone, about 5 miles higher and 3 miles behind Snoopy. Snoopy in another, be 40 minutes from now, a little more than that, will be firing he has fired his engines, but at that time will be sweeping around on this side of the moon and making that low pass of the landing site. The Charlie Brown is keeping a watchful eye over Snoopy and is prepared to go to Snoopy's help if needs it in these delicate maneuvers. In coming down to that 10-mile height, Tom Stafford said it yesterday, it's going to take some pretty sharp piloting to get into that 10-mile height, traveling at 3,700 miles per hour over the moon's surface with the jagged peaks and the uncertain pull of those mass cons. The United States and the Soviet Union have been sending unmanned spacecraft to the moon since 1959, and scientists have been studying the data that they returned. Well, last December, of course, Apollo 8 brought us the first look at the moon as seen by man with his own eyes. And now just 2 months from now, if all goes well, the first man will set foot on the moon. But even with all the information scientists have collected, many questions remain unanswered. And David Shoemaker reports.
Right, a little bit to your right. A little more, Right, okay, right in there. Now 20% of the model. See, we got a little more toward, okay, let's see how it looks.
Scientists have tried almost everything they could think of to learn about the moon without actually being there. For centuries, the moon has been studied through telescopes, studied by radio. It has been probed, scratched, and photographed. Rockets without men have slammed into her skin like guided missiles. Rockets with men have skimmed as close as 60 miles. For all that, the moon remains a mystery. And Eugene Cernan, one of the crew on this flight of Apollo 10, reflects man's enthusiasm about going there.
I think everything about the moon is unknown. All our history about the moon, about its origin, is theoretical. You know, why do we only see one face of the moon? We can project scientific reasons for this, but what is the moon's surface made out of? Is there any active, is it a dead body? Is there any active volcanic activity going on today? Is it really colorless? You know, it's almost inconceivable that a mass that big could be sort of a drab, colorless body. I think it's just a first step in finding out a little bit about the origin of our whole existence.
There are other questions, too, some basic questions just about getting to the moon. Although unmanned surveyor spacecraft have soft landed on the moon and taken enough pictures to provide an accurate mosaic of her surface, it is only recently that scientists have become aware of what they call mascons. First discovered on other unmanned flights, those of Lunar Orbiter, the effects of mascons became better understood after the Christmastime flight of astronauts Borman, Lovell, and Anders in Apollo 8. The word mascon is a shortening of two words, mass concentrations. All we know for sure is that they are points on the moon where the attraction of gravity is greater. As a result, as spacecraft pass over mascons, they drop closer to the moon and go faster. As they leave their influence, spacecraft tend to climb and go slower. Needless to say, astronauts who fly close to the moon are concerned about mascons, particularly their effect on a spacecraft about to make a landing. Trajectory experts hope to learn more about mascons from this flight of Apollo 10. And scientists are interested too, as Harold Mazursky of the U.S. Geological Survey explained.
Well, they're just as fascinating to us and as important to us as they are to the trajectory people, because this says that the moon is not homogeneous. That is, it is varied from place to place. And that tells us some very fundamental things. That is, that there is probably chemical differentiation on the moon, so that there are large variations in the chemistry and the gravity from place to place. This also says that probably there are circulation patterns like there are on the Earth. And what this really gives us is the fact that there will be ways that the moon is much more like the Earth than we thought it was originally. And we can hopefully, by studying it, learn more about the Earth too.
Learning about the Earth by studying the moon will be quite a reversal. Until now, geologists have been forced to base their conclusions about the moon mostly on studies of the Earth. It's been the only way, for instance, to train these amateur geologists who are trying to become professionals as quickly as possible. For they are Neil Armstrong and Buzz Aldrin, assigned to Apollo 11. This summer, they're scheduled to be the first men to actually set foot on the moon. It is only after they return that scientists will be able to abandon moon simulations such as this one on Earth. The proper study of the moon will finally be the moon. However, even that probably won't match the excitement of simply knowing we landed on the moon. We did it, and we can do more. David Shoemaker, CBS News, Flagstaff, Arizona.
And so the Apollo 10, the two spacecraft, are now behind the moon. The descent orbit insertion has been made. It was made 10 minutes ago when the descent propulsion system engine was fired behind the moon, as far as we know. We have not had that confirmation because they are behind the moon, no communication with the Earth. But assuming that all is going well, they have fired that descent propulsion system engine for some 27 7/10 seconds to slow them down by just 48.5 miles per hour, but enough to drop them out of their orbit into a lower perigee, the low point of the orbit, when they come around the moon the next time. We can show you approximately how this all happens. As they come around the moon, this time they will incidentally be just a little bit from the command module at that point, which you see coming around the moon. They come around in this fashion, and then coming down slower and slower, they come down to this point just 10 miles above the moon's surface. Then they begin to come out again. They fire their engines so that this time they will go into a very high orbit out here and eventually will be 350 miles away from the command module. They'll get out to their high point on the far side of the moon again, come sweeping down below the, down to the low point again as they come around this next time, and again 11 miles above the moon's surface. This time they fire to go back and rejoin the command module, and that rendezvous takes place on the far side of the moon also. All of the principal maneuvers of this dramatic part of the flight of Apollo 10 occur behind the moon, except for that dropping down to the moon's surface. The lunar module's firings take place on this near side of the moon, but the rendezvous maneuvers and the others take place on the far side of the moon. Bruce Morton at the Manned Spacecraft Center in Houston has a report now on what the flight controllers, mission control, are most anxious to learn about the moon in preparation for the flight of Apollo 11, the moon landing flight, and what they noticed most in yesterday's television pictures of the moon. Bruce?
Walter, they're doing one thing differently this time. David Shoemaker was talking about mascons just a minute ago, as we all have been off and on. The theory here now seems to be that while the mascons can be a hazard to a pilot in that they will suddenly speed him up or slow him down, that over a whole revolution, those effects tend to even out. And one of the problems they had on 8, you'll remember, was a difficulty in predicting where the spacecraft would be 2 revolutions from where it was, and that's the kind of prediction you have to make in order to achieve a rendezvous. The theory now is that the error in those predictions, which ran to 5 or 6 miles down track and perhaps a mile or so in height during the Apollo 8 flight, that those mistakes were really caused by the shape of the moon, which, as you know, Walter, is not round but pear-shaped with a substantial bulge sticking out towards the Earth, the result of the Earth's gravitational pull. So what they've done between the Apollo 8 flight and now is to make a new model of the moon's gravitational field based on data from the lunar orbiter flights and also from the Apollo 8 flight to feed that new model into the big computer here. And that way they hope to get much better data to feed up to Charlie Brown and Snoopy when they're telling them how long they need to burn and what the inclination should be and so forth. They expect that this new model will reduce the kind of error they had on 8 to perhaps a half a mile or less in length and just a few hundred feet in height, hopefully the kind of distance that these pilots can correct. We did talk yesterday with Jack Schmitt, the astronaut geologist who has been studying the lunar surface, who watched the television transmission yesterday and was taking extensive notes on what the astronauts said about the moon. He was impressed with the accuracy and the detail of their observations. He wasn't really surprised by anything. He said he noticed that they talked about volcanoes a good deal. That's an argument for those who think the moon has a volcanic history, but most geologists do anyway. He also noted that the astronauts saw the rills, those sort of creek beds on the moon, as having sharp outlines with no spillover. That's an argument for those who think they may have been made by water sometime in the past. But all in all, it adds up on this flight so far to a little more detail and no surprises.
A report from Bruce Morton at the Manned Space Center in Houston, Texas, where this flight is being controlled, of course. And those controllers on the ground deserve a great deal of the credit, of course, for this flight. Whether the pilots could possibly do this alone or not is never a question that's been raised because of the considerable support from the Manned Space Center. They are getting telemetry, except for this dark side pass around the moon. They're getting telemetry for an hour and 15 minutes out of every 2 hours of revolution of the moon. A full report on every function of every component of both the command module and the lunar module, and they are actually flying the mission there as well as the men in the spacecraft. But when Tom Stafford and Eugene Cernan get down there to that point right close to the moon, 9.6 miles was the determination of the Manned Space Center just a little while ago in figuring their orbits, and they'll get another figure on that as they come sweeping around to our side of the moon very shortly. They will, then Stafford and Cernan will be eyeballing as well as using their radar to get right down there to that 50,000-foot high level. CBS News color coverage of the flight of Apollo 10 will continue in a moment.